Hi, my name is Melvin Perez. I just came back from a customer in California working in communications, and I was delivering a developer testing class, and I got this question I get all the time, every time I teach this class. Usually people ask me, how can we apply all of these fancy testing techniques when we're dealing with legacy code? So the first thing I ask them is, how do you define legacy code? And we'll get all kinds of answers like, well, code that was written by somebody else, code that it was written by somebody who is not here anymore. But at the end of the day, the common denominator is that legacy code is code they are afraid of touching, code that they don't want to interact with. The reason for that is because it is legacy code, it was written by somebody else, that's fine, but also is the code that is running the business somehow. If not, they will have replaced it already. If they have a way to replace that code, they have done it already. But the other thing is that legacy code typically doesn't have any way to tell you when you're breaking it. So they don't have automated tests. So the best definition that I have for legacy code is code that you're afraid of interacting with, or code that has no automated tests. If you have automated tests, you can feel more confident going in and making some changes because you know that you can use those tests as safety net. It will tell you, hey, you're breaking something, and then you will not be able to get something in the code that could be problematic. The other concept that I usually go over is this idea of legacy code dilemma. And this is something that Michael Feathers talked about in his book, Dealing with Legacy Code. So essentially what this dilemma means is that you now want to make legacy code more testable. But now in order for you to make that legacy code more testable, you have to change it because it was not written in a way to be testable. So the fear is that now you're going to be making it more testable. Chances are that during that time, you're going to be introducing a defect. So how can you deal with this? You definitely have a good intention. You want to add automated tests, but you don't want to break the code during that process. So one thing that you could do is first start with what we call characterization test. Characterization test is essentially a test that you know is going to fail. And sometimes you're dealing with legacy code, you cannot even tell what is the behavior. You want to make a change, but you don't want to change any existing behavior. So what you do is to write a test in which you're going to behave saying, well, the expected outcome is X, something that you know is not the right answer. So the test will fail, and the test will also tell you why it's failing. So in other words, you'll be able to see this is what was expected, this is what is being returned. So now you can take that and make it part of your test. So essentially you're characterizing what the code is doing, and you're going to put that in a test. And then you can go on and start basically implementing your changes, and you're going to be looking at that test to make sure that it's not being broken. Now the other thing you also want to do is you have an entire code base, it's big. You cannot pretend to add tests everywhere. So you're going to need to look at what specific area of your code is the one you're going to be changing. So you definitely would like to write tests for that area in particular. And you would like to measure coverage. So you execute those tests with a code coverage, and then you'll be able to see that the area of the code you're going to be changing is actually being covered. If you don't do this, maybe you're testing something else. You're going to be changing something, and that safety net will not save you. So make sure you do this. Now, the other thing is, how can we go about introducing these changes to make your code testable, and I would say in a safe way, something that you're not feeling like you have high chances to break the code? One thing that you can do is make sure you leverage your tools, your refactoring tools. They're actually very powerful. Many of the changes you need to do is something that a refactoring tool can do for you. What is the benefit of using a refactoring tool versus you doing those changes manually? Well, this tool will ensure that the code will remain consistent. Even when you change a variable name, when you change a function name, when you add a parameter, all of that the tool will do is to make sure that the entire code will be consistent with this new state. And now that you have those characterization tests, you can re-execute those tests, and you're still gonna see that your code is not being broken. Once you have this, then you start feeling more confident and going in and start writing, your changes and so on and so forth. So the other advice that I have right here is when you start writing those tests for the area of the code you're gonna be changing, it is definitely hard to try to go and write tests for, I would say, the deepest part of your code. Because in order for you to reach that level, you will need to know all the things that need to be in place in the system for you to be able to reach that code. So our advice is to start writing your tests using an outside-in approach. Outside-in means that you're gonna be looking at external behavior first. You're gonna start to find, if you're measuring coverage, you're gonna start looking at maybe the beginning or the end. When you see those, if this is not true, then exit. That's the first part you wanna test. And you're gonna keep going deeper in your code until you reach the area that you wanna test. Now, in terms of refactoring, you're gonna be refactoring inside out. Once you have sufficient coverage, then you're gonna start looking at, this smaller function that you have right here that you want to add a parameter or rename. Then you start from there, you keep going, all the way back. Now, the other piece of advice, and usually is something that, will answer the question about like, well, what if we don't have the time, which is usually a complaint about legacy code. So those all advices looks fine, but they will say, well, we don't have time for that. Well, there is rarely that time. There's rarely chances that you're gonna have like an entire project to go ahead and maybe improve the code, refactor the code to make it testable. The best thing you can do for your future is to every opportunity, for every change, go through this set of advices, and that will change your future. And nobody else can do that for you. So you're gonna need to take that. You don't even need to report it, saying, I'm gonna be refactoring this code. You should go ahead and do it. You're gonna feel maybe at first it will take a little bit longer, but you're gonna save time in the future. So just go ahead, take that initiative and start improving your code. That's how that code ended up in the state that it is today. It's because we were not applying good practices. Now you know all of this. Start changing your future, making sure that in the future the code will look better for you and anybody else will come up. So that's what I have here for legacy code. If you'd like to see more, you're gonna find more content in our on-demand class, and also we're gonna share some reference on how to deal with legacy code.